Hi everybody. We will think about integration today. When you think about integration, you should remember about differentiation. Because differentiation and integration are inverse process. We will come to that. Before that, you should remember what is differentiation. It's a derivative of a function. Then you may think what is a function. You should remember what is a function. A function comes from a relation, and a relation comes from cross product, and cross product comes from sets. So there is a lot of things that you should remember when you study integration. Okay, I'm not going in detail about all those things, but instead we'll think about our topic in integration. Let me write a function. F of x is equal to x cube. If you differentiate this, you get f dash of x or dy by dx is equal to 3x square. So, x cube when you differentiate, you get a 3x square. So, I can say this is 3x square is the derivative of x cube. How can I call back what is x cube for 3x square? We can call it as the primitive. Primitive of 3x square is x cube, or we will call it as an antiderivative. Now the question is, can we get from 3x square back this x cube? Yes, that inverse process is called integration. Integration, the word meaning is sum. Sum means S-U-M. This letter S, its elongated form is this one. So this is the symbol we use. So if you integrate 3x square dx, as per our definition, this should become x cube. Of course, it is going to be x cube only. Before I go into the detail of this, how we integrate by using formula, I just wanted you to focus on this. See, if I differentiate x cube, I get 3x square. If I differentiate x cube plus 1, still you will get 3x square, right? Because you know f dash of x is 3x square plus 0. If you differentiate x cube plus 4, f dash of x equal to still 3x square. If you differentiate x cube minus 10, you get f dash of x is equal to 3x square. So 3x square has got how many primitives? So many primitives, so many antiderivatives. So how do we represent all together? So if I get 3x square, from 3x square, how do I know whether I should go to x cube or x cube plus 1, x cube plus, we do not know. So in general, we will say the primitive of 3x square as x cube plus c. Since we do not know this value of c at present, we call it as indefinite integration. Indefinite integration. We have a second part for this, that is definite integration, where we will not see c. The c, or you can use the letter k also, the constant of integration. We will go to the second part on a later time. First, let us learn about indefinite integration. So if you want to learn about indefinite integration, it is, of course, it's, as I said, it is the inverse process only of differentiation. But we should understand more than that. We don't have to learn much about the concept, or instead we should just understand that it is the inverse process of integration. We should know about how to integrate. That is a technically with the help of some formulas which we are going to discuss. These formulas are thorough, then to a very good extent you will be capable of integrating. There are many techniques involved with the different questions. Different methods are there, that all will be discussing. So we'll start with the first formula is integral x power n dx. Looking at this dx or dy, we will say with respect to what variable here I will integrate it with respect to x. So this is x power n plus 1 by n plus 1 plus c. This is the first algebraic, this one. In formula in this algebraic we have x power n, e power x, 1 by x, a power x. Then we have trigonometric formulas, inverse trigonometric formulas. We will come to that. Around 10 trigonometric formulas, then 6 inverse trigonometric. That will be the first few formulas to be learned, or the main work is related to that. Now, if with this, if I have x power 5 means my integration answer will be x power 6 by 6. X power 10 means x power 11 by 11, and so on it will. So adjacent to that, if you want, you can think about what will be integral 1 dx. 1 dx is x power 1 it will come, or it is just x plus c, because if you differentiate x you will get 1. Whatever answer you write here, if you differentiate you get it back. 1 by n plus 1 into n plus 1 x power n plus 1 minus 1, n plus 1 cancels, you get x power n back. Now integral 0 dx, what should be the answer? It is just c, because any constant when you differentiate you get 0. So we can write it as c. These are certain things which you should remember as a corollary for this formula. Second formula that you should remember is integral a power x dx, which is going to be a power x divided by log a plus c. Third one, where a is a constant and x is a variable. X is x only. If I have 2 power x, I will write 2 power x divided by log 2. Integral e power x dx. E is also a constant to the power. So the answer will be e power x by log e, the same formula when I use, but to the base e only v. So log e to the base e is 1. So we need not write this e power x as like this, because it's 1. So e power x will say the integration is e power x itself. Now the fourth one is integral 1 by x dx. You may remember, when you differentiate log x only you get 1 by x. So this is log mod x plus c. We put modular sign so that we make sure that this x is not negative. Okay, these are the first 4 formulas that we should discuss from algebra. Now I should tell you the remaining 10 formulas are going to be our trigonometric formulas. Trigonometry, the first one, let us start with the number 1. Integral sin x dx. That will be minus cos x plus c. Because the reason is cos x, if you differentiate, you will get a minus sin x. With this minus, it will become plus sin x. Second one, integral cos x dx, which will be sin x plus c. Sin x differentiation is cos x. Third one, integral tan x dx, which is equal to log mod sec x plus c. If you differentiate this 1 by sec x differentiation numerator, it will become sec x tan x, sec cancel, you will get a tan x. Fourth one, integral cot x dx, which will be log mod sin x plus c. If you differentiate this 1 by sin x, and sin x differentiation cos x in the numerator, so cos by sin, you will get cot x back. What I am trying to say is that these answers are correct. So the fifth one is, the fifth will write integral sec x dx, which is equal to log mod sec x plus tan x plus c. If you differentiate this 1 by sec x plus tan x, and numerator, this sec x plus tan x differentiation, if you write sec x tan x plus sec square x and take common factor, you will get this stuff back. Therefore it's correct. Sixth one, integral cosec x dx, which is equal to log mod log mod cosec x minus cot x plus c. This also when you differentiate 1 by cosec x minus cot x, then this inner function cosec x minus cot x, numerator it will become cosec x minus cosec x cot x minus cosec square x. If you take common factor, you are going to get back this cosec x. So these are the 6 trigonometric functions that you should learn. In addition to that, through differentiation we have 4 more formulas that we will discuss next. So including that we will be having 10. So which are they? The first one is integral sec square x dx, which is equal to tan x plus c, because tan x differentiation is c square x. Integral, this we can call it as 7th one, and 8th one, it is sec square x. What is the difference? What function when you differentiate you get cosec square? Actually when you differentiate cot x, you will get a minus cosec square. To manage that minus, let me put that cot x minus cot x. So you will get minus minus, it will be plus c. And 9th one, integral sec x tan x. You may remember, those who know the differentiation formula, this will be easy. You have to think it backward. What when I differentiate, what I get? This sec x tan x, that is sec x plus c. And 10th one, integral cosec x cot x dx, which will be minus cosec x plus c. Minus cosec x differentiation is minus cosec x cot x. At minus and this minus, it will become this. So these are the remaining 4 formulas. So I said 6 plus 4, 10 trigonometric formulas. Now after this we need to think about the inverse trigonometric formulas for each of the function. That means we have 6 functions, right? So integral 1 by root of 1 minus x square. First inverse. This you see in the differentiation of sine inverse x plus c. Integral minus 1 by root of 1 minus x square dx. This will be cos inverse x plus c. Third one, integral 1 by 1 plus x square dx, which is equal to tan inverse x plus c. Fourth one, integral 1 by minus 1 by 1 plus x square dx, which is equal to cot inverse x plus c. And fifth one, integral 1 by x into root of x square minus 1 dx. This is sec inverse x plus c. And sixth one, integral minus 1 by x into root of x square minus 1 dx, which is equal to cosec inverse x plus c. Cosec inverse x plus c. So these are the 6 inverse trigonometric formulas which you need to learn. After this we have got special integral formulas are there. Then different methods we have to learn some more formula. But basically you should remember these many formulas. In that itself, these first 4 are very important. We can have it in many questions. So that's how all about the formula. After this we will start the exercise. One by one we will do and make sure that we learn integration in a better way. Okay, thank you. But don't forget to learn all these formulas.